Okay, so let's talk about inter-shard communication. How do the 64 ETH shards talk to each other? And then we'll go to Sunny about how that's different from how IBC functions. Or if IBC could be lent to
I think it could. And I think that the ETH2 doesn't have to actually care from a core protocol standpoint. And maybe there are certain things, like based on this conversation or others, that, like, you know, if you make one decision this way instead of that way, it can be like much better. But so we have this beacon chain. This is the core system chain, and validators are always like making these cross links from the shard chains back into the beacon chain. And what that really is just really like making a claim about what the head of a shard chain is, and making sure that the core system knows about it. And this is good because then the core system can finalize these heads, but it can also, all of these shards, they always kind of know, if I'm syncing a shard, if I'm running a shard, I always know about the beacon chain as well. So like the beacon chain is this like consistent piece of overhead and knowledge across the system. And so if I'm running shard B and I see a recent crosslink from shard A into the beacon chain, what that is it manifests as a Merkle tree root. And a Merkle tree root is essentially like a digest of that recent block, about data and state and transactions and things. And with that digest, the 32 byte digest, I can then make claims and proofs about the other shard. So for example, if on shard B, I need to reference like the balance of something on shard A, I reference this Merkle root and I bring in a little proof, a Merkle proof. And now I can like make a claim about what that is and prove it to my applications and to other users.
Does every single block have to, like every block on a shard has to be sent as a digest to the beacon chain?
Yes and no. So it's always, in the optimal, we're cross-linking all shards at every slot. But these shard chains, like if shard A has a few slots that are missed, then those three blocks, there'd be a claim made about all of them back into the beacon chain. But the beacon chain would just remember the head of that head digest. Because that head digest, then one, it has reference to like historical accumulators, it has reference to state. You can make claims about previous blocks via it being a blockchain. And so that head really is enough of a digest to make the claims that you want. So it's always just remembering one reference, and that's the most recent crosslink, and the most recent head that it can know about. And so,
sorry, one more. Sorry, just to understand it, do the shards also have a consensus protocol, or is the consensus only happening on?
The shards have a fork choice. Okay. And so generally a shard is like one block. Like you go to the most recent crosslink in the beacon chain, and you probably walk like one block to find the head of the shard chain. But in the event that cross-linking is not happening optimally, these previous votes on attempts to be a cross-link serve as like votes for the head of that chain. And so you actually get like a little sub ghost chain off of the beacon chain. And so it's not, the consensus mechanism is to fully bring these into the core of the system, the beacon chain, and to finalize them. But the liveness of following them is with respect to these the fork choice off of the shard, off of the beacon chain.
The crosslinks sound really complicated. So so is it true that the beacon chain does not hold all of the data? It just holds what? It just maintains a Merkle tree with all of these different proofs?
Right, so the beacon chain has this like core system state, and one of the components is a crosslink, a latest crosslink for each shard, which is a reference to the head of that block. And so the data, when I'm cross-linking these things, I'm making cryptoeconomic claims about the availability and validity of the data back into the core system. There's a number of mechanisms that we use there. We can get into them if you're interested. I was just working on some specs today. But the core, to run just the core of the system, I don't need to have all of the data, all of the shards. But if I run the core of the system, I can then sync and run any number of those shards.
So if I were to try and query, let's say 1,000 blocks before then would that entail several hops through these different cross links just to get back to like the shard where the data was stored?
Query from which respect? What do I want to know?
If I wanted to like a proof about something that happened, 1,000 blocks ago, how does the logic? How do I retrieve data and ensure that it's true?
Right. So if I want to, there's a number of things there. If I'm just running the shard chain with respect to the beacon chain, it's just like running a normal blockchain. But if I wanted to make proofs about some other shard chain, then there's a number of like I can go then make proofs through this cross-link to anything about that shard. And we add some like extra fun bits called double batch Merkle accumulators, which make it so that I don't have to go, it makes it so that if I'm querying historical things, if I'm not querying, but if I'm making proofs about historical things, it reduces the depth of those Merkle trees. And really what you're looking at here is the expense of a proof is the depth of the Merkle tree. And so you can just through that single cross-link go as deep into history of that entire chain as you want via jumping back, but there's a couple of like helper accessors that kind of batch history into these more easily more easily provable things, more easy in the sense of Merkle tree depth. But there's probably a few things there. Like if I want to actually just, generally if I'm doing cross-shard communication, I'm making proofs against the latest crosslink because I am making proofs about what is there, what is the head of the state. Similarly, if I'm going to the Cosmos hub and I want to communicate about something, I can't necessarily like making a claim about the token history 1,000 blocks ago doesn't like really help me make claims about the tokens that I can use and stuff. So like the head chain with respect to like cross-shard communication is primarily what I want. But you do have the ability, and in Ethereum today and in most blockchains, like Merkle trees are like the backbone of these things. And also because it's a blockchain, you can make like arbitrary proofs about pretty much anything in the system and anything historically. It's just a matter of like what the complexity of that proof looks like and like the depth of that proof.
Gotcha. And so,
can shards talk directly to other shards, or does all communication have to get routed through the beacon chain?
It has to get routed through the beacon chain. And this is because once I start allowing direct communication, now I've premised like the state and the fork choice and the consensus of these separate shard chains on each other. And so if like one got rolled back for any number of reasons, then that could trigger rolling back another chain, which could trigger rolling back another chain. And you all of a sudden have like, if you allow direct communication, you've now allowed kind of this like the entire system to be brittle upon itself and like blown up the complexity such that you probably just need to follow all shard chains at all times and lose all your scalability again.